Okay, great. Well, welcome everyone. Thanks so much for joining us today for our SIMAP webinar on new functionality. We're really excited to share these updates with you, which we just released last month in January 2021. So first, we'll be talking through a little bit of background, just to make sure everybody is on the same page and knows a little bit about SIMAP. And then we'll get into the new functionality. First, we'll talk about some biogenic updates. We've separated out biogenic emission factors and also added a biogenic report for viewing your biogenic results. Then Ben Robinson will take over and tell us about the 2020 version of emission factors, where we've updated to the most current data and added the option to view your results using 20-year global warming potentials, which is in addition to the standard that we've had of 100-year GWPs. And then the last bit of new functionality is 2 new air travel method selections that we brought forward. Then, since we know that many of you all have very different commuting data over the last year, we've released some guidance, made some minor changes to remove restrictions for commuting data to make it easier to enter your commuting data for the past year. Then we'll have a few updates on some ongoing SIMAP work, and we'll have plenty of time at the end for questions. So as I mentioned, we are recording this webinar, and we're posting both the recording and the slides afterwards on the resources tab of the SIMAP page. And also throughout, as questions occur to you, please just post them in the chat. We'll be keeping an eye on those, and we'll do our best to get to all of them during the Q&A session at the end. So before we get into the details of SIMAP, we just wanted to introduce you to our team here. So I'm Allie Leach, and I'm a postdoctoral researcher with the UNH Sustainability Institute, where I work on the day-to-day SIMAP user support and research and development. So if you send an email to the SIMAP inbox, it's probably me that is responding.
Thanks, Allie. And I'm Jen Andrews. I'm a project director at the UNH Sustainability Institute, where I've been almost a decade now. And I realized this month is the month in which I can say, for better or worse, I've had the pleasure of working with many of you on sustainability, climate, and higher ed leadership for 2 decades now. So great to be with you all.
And I am Ben Robinson. I am a technical program assistant here at SIMAP. I've been working with Allie Leach and Jen Andrews and Cassidy here for the past 3 years. My work mainly focuses on emission factors and resources, and I've been working on a lot of the new functionality that we are going to demonstrate for you here today.
I'm Cassidy Yates. I'm a graduate student at UNH in environmental engineering, and I've been interning with SIMAP for the last couple years, and I primarily work on data reviews.
Great. So just a little bit of background on SIMAP. What is SIMAP? It stands for Sustainability Indicator Management and Analysis Platform. And it's a web-based tool for calculating campus carbon and nitrogen footprints. It allows you to track, analyze, and gives you the tools to improve your campus-wide sustainability over time. And we released SIMAP in November 2017, so just a little over 3 years ago now. But it was preceded by 2 Excel-based tools that many of you used. First, the carbon tool went by many names over the years, the Campus Carbon Calculator, Clean Air Cool Planet, and others. And it was integrated with the nitrogen footprint tool, which was developed at UVA, also Excel-based, and went through pilot testing by a group of 2 institutions. And at the most basic level, SIMAP works by taking your activity data and using that to calculate the footprints. So you enter your activity data across categories. Here they're organized by scope. So for example, your on-campus stationary fuel use, your direct transport fuel use, purchased electricity, commuting, and more. And you enter that data and you get out both footprints. And the same activities contribute to both footprints. So anytime you burn a fossil fuel, you're releasing greenhouse gases like carbon dioxide, methane, nitrous oxide, and also releasing forms of nitrogen. Nitrous oxide as well for the nitrogen footprint, and also nitrogen oxides, which contribute to local air quality problems. With this integration, we were also able to add in a new category that's really important to food, really important to nitrogen and also pretty important to carbon, and that is food. The food footprint makes up more than half of the nitrogen footprint usually, and makes up about 5 to 15% of a carbon footprint. And since we know that many of you report to ASU STARS as well, we wanted to mention that there are many credits in STARS that you can use your SIMAP results for. So for example, you can use your SIMAP results to enter your greenhouse gas inventory into STARS. The nitrogen footprint is now an exemplary practice credit in STARS. In the air quality portion, there's a section for entering your NOx emissions, which can be calculated in SIMAP. In the purchased goods category in STARS, the food data that you enter into SIMAP can be modified and entered for STARS as well. And if you complete a data review with our team, which we'll be talking more about later, you can also get the STARS credit for the third-party greenhouse gas inventory review. So I just wanted to briefly walk you all through how SIMAP is set up. This is the homepage here that has some basic information about the tool. And in the newsfeed on the right, we update pretty regularly with big updates. So you can see at the top here, it mentions the webinar that we're on right now. We always post our newsletters here in case you're not on the distribution list, and other big updates. Like when we released all this functionality in late January, we posted links to pages describing the key updates. Then SIMAP is organized with these tabs across the top that are generally in order of the flow of information that you enter. So the next one is the account tab, which is where you enter your overarching institution information. So your institution information, like its climate zone and its zip code, would go in the institution page. If you have a tier 2 account, this is where you would enter your secondary campuses. So you could enter data for those additional campuses. It's where you can add users to your account and put entries in the notebook, which is an overarching place to keep notes that apply to your overall account. And it's also where you enter any normalization data. So your budget data, physical spaces, and populations. And you would need to enter that here if you want to view any normalizations on the results tab. Then the data entry tab is where you probably will spend most of your time. This is where you actually enter your activity data. And this landing page has links to some content pages that provide more information about some of these categories and gives an overview of the data entry. And then you can click on any one of these links on the left panel here to enter data for that specific category. And at the very bottom, which you can't see here right now, there are also links where you can view the emission factors associated with your account. Then next is the results tab, which is the more detailed view of your results. First, you can select which footprints you want to view. You can view both or just one at a time. And there's different report types here. You can view your footprint based on the total footprint, which has your net footprint and also adds on your biogenic footprint and accounts for any sinks and offsets. And the total footprint is the only view where you would see those categories, the biogenic, offsets and sinks, because those aren't tied to a specific scope or category. Then the scopes view shows your footprint by scope, scope 1, scope 2, scope 3. And this is the categories view here, which shows the breakout across the detailed categories. The most detailed view is the sources report that actually doesn't have a graph because it has so many individual line items. It lists a table that provides your results for every single source. Then the gas pollutant view shows you your footprint by emissions category. So by CO2, by methane, by nitrous oxide. You can also pick your scope 2 method here, graph type, your range of years, and any normalizations that you want to run. And one thing I did want to mention for graphs is that these are all customizable. So you can click this link to learn more about the graphs. And you can, for example, remove categories from a graph by clicking them in the legend, or you can view just one category at a time by double clicking on a category. Then the reports tab also shows your results, but shows it for specific topics that we've organized. And so you can see a full list of those here. The annual report is what we're viewing right now, and there's always a table associated with what's displayed in the graph. There's also a food report that looks at the weight of your food and the emissions associated with your food by category, by food category. a commuting report, a second nature report, a grits report, which is a pretty new one, biogenic report, we'll be talking more about that one later today, and a campus comparison report, which is for tier 2 accounts. Then the data management tab is where you can make general method selections for your account. So where you can pick your emission factor version, or you can select your eGrid region. We'll be talking more about these other selections later today. It's also where you can enter that a year is complete for your data entry on the status page, also where you can import, export, and delete data. And this also has the page for requesting a data review and getting more information about a data review. Then we'll be talking more later today about the resources tab. So with that, we'll get into our new functionality here. So I'll be starting with the biogenic background, and then Ben Robinson will tell us more about the 2020 version of emission factors, 20-year GWP, and the air travel methods. So biogenic is a category that has been in SIMAP, but the calculations have happened behind the scenes. And so we wanted to bring this forward. The updates that we've made have helped make it more transparent and also customizable. So first, a quick definition. So biogenic CO2 is the carbon that is in biomass sources like wood and paper and grass trimming and other biofuels. And it's CO2 or carbon that was removed from the atmosphere by photosynthesis, so by natural processes. And it's carbon that also under natural conditions would eventually cycle back to the atmosphere, CO2, during decomposition and degradation processes. So basically, when we're burning a biomass source or a biofuel, we're just speeding up a natural cycle. It's on a shorter time scale than it would have been if it had naturally decomposed and gone back to the atmosphere. And these emissions, they are happening. So there is CO2 being released to the atmosphere. So it's very important to count it. And we recommend tracking the biogenic portion of your footprint. But the Greenhouse Gas Protocol does currently consider these emissions to be carbon neutral because they're speeding up a natural process. And so in your footprint, these biogenic emissions won't be added to your net footprint. They would be reported separate from your footprint. So in addition to your net footprint. And these are the sources that we have for biogenic in SIMAP right now: Scope 1 stationary fuels and Scope 1 transport fuels. Some of these are 100% biogenic, like wood chips and wood pellets. Some of them are mixed, like incinerated waste. It's just over half biogenic, and there's a number of biofuels that are mixed fuels and partially biogenic, like B20, for example, is 20% biogenic. And right now, we only have the Scope 1 sources for biogenic in SIMAP. In the future, we're going to be adding in Scope 2 and Scope 3 biogenic emission factors as well. So the first update that we made for biogenic was we separated out the emission factors. Previously, the total CO2 emission factor was shown under the CO2 category, and then SIMAP would calculate your CO2 emissions by the percent biogenic to allocate those emissions across non-biogenic and biogenic CO2. And we wanted to make these more transparent and also customizable. So we separated this out. So if you click on the CO2 emission factors now, you'll just see the non-biogenic CO2 portion of your footprint. And if you click on the biogenic portion, you'll just see the biogenic part. And importantly, it's now possible to customize your biogenic emission factor. So if you have a unique biofuel source on your campus, you can enter that, customize the factor, and track it. And you can view all and customize all of these emission factors through the data management, the data entry tab and the emission factors page. We also created a new report for you to view your biogenic emissions. This can be viewed on the reports tab, and you can select biogenic emissions from the dropdown. And this is the only place where you can see your biogenic emissions by category. So you can see this graph here shows the biogenic emissions by cogen categories, other on-campus stationary, and direct transport. This also has a graph of the total footprint. Because the biogenic footprint isn't part of a scope or category, it's separate from that. So you can see your net footprint with the biogenic footprint as well. So how those two would total together. So this is the first in a series of reports that we'll be releasing. Next, we'll be releasing a campus lands report that will bring more details about campus land management into a report, and also a carbon neutrality report. And I also wanted to thank the Biogenic working group who provided feedback on the Biogenic updates that we've been making in SIMAP. We really appreciated and valued their input throughout this process. And with that, I'm going to turn it over to Ben Robinson, who's going to tell us more about the 2020 version of emission factors.
Thanks, Allie. So yeah, I am Ben Robinson. I've been working on this year's update to the emission factor version, as well as last year and the year before. So I'll just give you a overview of what has changed. One thing that we do like to do every single year is update the source data that goes into our emission factor calculations. So you can see here, we updated the carbon contents and the heating value that go into actually calculating our emission factors. The heating values come from the EIA, and most of the carbon contents come from the US greenhouse gas inventory. So these are both from the most recent reports. The US greenhouse gas inventory is actually for only up till 2018 data. So that's where we're going to. We also made some updates to the mile per gallons values that we use for some of the commuting factors and things like that. Some of the other big updates that Allie was talking about in scope 1, we separated out the biogenic emission factors from the CO2 emission factors. That is where you will see the largest change in the emission factors if you're comparing version to version and comparing year to year. In scope 2, the only update we made was updating the residual electricity emission factors, as those have been, a new version was released from Green E, which is our source for residual electricity emission factors. In scope 3, one update that we made is to the waste methodology. We basically are continuing to use the warm model as we have been in the past, but we have gone back and looked at previous versions of the warm model as well as current versions of the warm model and updated the factors as the waste composition changes over time. A few other corrections that we made that Allie briefly touched on, E85, we have changed from being 85% biogenic to 74% biogenic to better reflect the actual composition of the average ethanol E85 mix in the United States, and did an error correction from residual and distillate bioheat. Previously, these were 100% biogenic, and now they are only 20% biogenic. So just going a little more into detail here for the scope 1 emission factors. Like I said before, the carbon contents and the heating values have been updated. The biogenic emission factors are now separate, and there was a correction. Some examples of things that have changed a little bit with the updates to the carbon contents of the heating value. The largest change you'll see probably in scope 1 stationary is the propane emission factor is reduced by 3%. The coal emission factor is increased by less than 1%, and all of the other stationary combustion emission factors have been reduced by less than 1%, in most cases less than 0.1%. So very small changes there, probably not even that noticeable. Transport fuels, again, there are similar updates to carbon contents and heating values for things like gasoline, diesel, things like that. The largest changes are to the biogenic percentages in E85, and again, no large change there. Fertilizer emission factors for scope 1 have not been changed at all. For the emissions from animals, for the CH4 and N2O emissions that we calculate for animals, there have been a few changes due to using the new greenhouse gas inventory data. Some of those might include methane emissions from swine increasing by about 5%, and the N2O emissions from goats and horses have been reduced. Refrigerants and chemicals, which are also part of scope 1, we've made a few minor corrections to the species names, and then there is also now the options to view these results with the 20-year GWPs, which I will discuss a little more later on. For scope 2, like I mentioned before, the only update in this version of the emission factors are the residual based residual factors for the market-based approach, and there are so the location-based emission factors have not been upgraded because there has not been a new release of eGrid since last year's version. In scope 3, there have been a number of changes to the commuting factors and business travel factors. This is also due to the same changes I discussed earlier with updated carbon contents and heating values and updates to average MPGs. Some of the more significant changes here is the train emission factor in recent years has gone up by about 5%, but all of the other mobile fuels and sources have actually decreased by less than 1%, in some cases less than 0.1%. So again, very small changes. For food and paper, emission factors have not been updated this year. And for waste, as I discussed just recently, we have updated the emission factors across time using the previous versions of the WARM model so that they reflect how the waste composition has changed across time. If you want more information about these emission factor versions and all the changes that are in each version, you can go here on the resources tab to this EF versions page, and you can get more details on each emission factor version going back to 2017 for each scope individually. One slide here about talking about which these emission factor versions and giving some guidance about which version we recommend. So a new feature in SIMAP that Ali might have touched on a little bit, we now have recommended methodologies on the data management tab, and you will see that the 2020 version of emission factors is now recommended. We recommend this for all years of your footprint calculation. Every time we update these emission factor versions, we update all of the emission factors back to 1990. The reason those previous years of emission factors might have changed is new data sets become available, like I mentioned, heating values and carbon contents, or one example being the WARM model, or new methodology are recommended, so we change our calculation methodologies. The reason we recommend updating to the 2020 version for all years of your inventory is, one, just to get the most accurate results that you can, and then two, so when you're comparing across years, your changes in emissions are actually representative of changes in emissions and not changes in accounting methods and things like that. Just a brief slide here before I talk about the 20-year global warming potentials on global warming potentials. Basically, what GWP does is normalizes these other global warming gases to be the equivalent to carbon dioxide so that we can add them all up and kind of balance them against one another and get a sense of the total impact. There are different versions of these GWPs, which we will see briefly, but the standard version that in our recommended version as well, and what's used in most greenhouse gas inventories is the 100-year fifth assessment report GWP, which has the values that you can see here. There's an example calculation at the bottom where you just show how you multiply methane, for example, by its global warming potential, so you can compare it directly against CO2 emissions. So the 20-year global warming potential. So the 100-year global warming potential that is most commonly used describes the warming effects these gases have over 100 years. The 20-year GWP is just describing these effects over 20 years, and there has been a discussion among the climate change community about also looking at emissions from this perspective, so we get a better idea about the short-term warming potential for things like methane and methane sources. So here you can see the 100 GWPs and the 20-year GWPs for the three most common GHGs here. And these are now going to be options in SIMAP that you can choose and select. So as I was saying before, most greenhouse gas inventories use the 100-year GWPs, and we still recommend using the 100-year GWPs for your inventory and for tracking across time. What the 20-year GWP option does is provide you in a different and additional way to look at your results, basically on a on a shorter time scale, looking at shorter term warming and things like that. So just additional options for everyone. One of the last two updates that I'm going to talk about is updates to our air travel methods. This is an update to our passenger yield calculation. So you can enter your air travel data into SIMAP in US dollars in terms of dollars spent on air travel. And we use national statistics to calculate air travel passenger yield factors to convert that dollar spent into miles traveled. The update here is that we have a new data source for this conversion factor that we're using. The data source that we were using before is no longer being updated, and so that was getting more and more out of date. The new data source is from the Bureau of Transportation Statistics and their airline origin and destination survey that they do actually quarterly. And this is a large data set over millions of data points, and basically they have a data point that is fare per miles flown. We take that data, remove outliers, and take the median value to calculate our conversion factor here. The differences from the previous version to our newer version of conversion factors is that this new data set includes taxes. So includes the taxes on the ticket in the total dollar cost, and the old data set did not. And the difference here is our new factors are lower, and actually the new factors are higher, so higher dollar per mile traveled, and so the resulting emissions using these factors are slightly lower. The only other update to air travel methods that we have made is the addition of another radiative forcing factor option. Radiative forcing factor is used to account for the higher global warming potential from emissions that are released at a higher altitude. So basically at different points in an airline's flight, and emissions at different altitudes can have different effects due to a variety of atmospheric effects, including increased albedo, contrails, the ozone cycle, things like that. So the radiative forcing factor, what it does is multiplies the CO2 emissions to account for all of these additional effects. We now have two options in SIMAP, both a factor from the IPCC, which is 2.7, and a factor that is used by DEFRA, which is the UK Department for Environmental, Food and Rural Affairs. We have both of these available. We recommend using the IPCC value. Basically, our point of view on this is science that is still in development and still unsettled. So we are erring on the side of being conservative. That's why our recommended version is the IPCC 2.7 factor. And as I was discussing before, here are the recommended methods and alerts. Allie?
Sorry about that. Can you all still see my screen here?
Mm-hmm.
Okay, great. So thanks so much, Ben, for those updates on the new methods here. So as Ben mentioned on the data management tab, we now highlight for all of these methods what the recommended method is. So here you can see for the emission factors version, the 2020 version is recommended. For global warming potential version, AR5 100 year, it continues to be the recommended version. This is where if you want to view your results in 20 year, you can make this selection here. And the air travel cost version, the BTS version is the recommended one, the new one that includes taxes and the conversion factors and the radiative forcing factor. Each of these have info icons next to them that have more information. And we also have content pages that explain each of these in more detail. And we do have, you may have noticed lately that we have more alerts and more messages that pop up when you're on the results tab to let you know when you're not using a recommended version or when a calculation factor is missing. And the alerts will pop up in yellow when there's a method that is not recommended that you're using. And you can continue to not use a recommended method, but we just like to let you know when that's the case. And it'll also tell you in red when there's any missing calculation factors or missing emission factors. We also have a number of content pages here that are related to the new functionality. So we have a page all about biogenic emissions that explain what they are and how to use the biogenic emissions report. We have the global warming potential versions page that explains the different versions and the difference between 100-year and 20-year. And we also have a page all about the air travel emissions factors. Okay, so that's everything for new functionality. And now we'll talk a little bit about commuting guidance in SIMAP based on some updates that we've made and some guidance for your 2020 data entry. So first, we have two recommendations for your 2020 data entry. And this is to accommodate different commuting patterns that may happen, that probably happened on your campuses as a result of a shutdown from COVID. And so what we're recommending is that you enter your commuting data in different time periods to reflect the different commuting patterns. So in this particular example, we have a first entry here that goes through March 31, 2020, and this would be the standard commuting practices for this particular campus. And then you could have a second entry that reports the different commuting patterns that might have happened after a shutdown. So you can see that this would be a smaller number of commuters in this case. And a very important data point is the commuting weeks per date range. So although you do enter the actual date range, SIMAP actually uses this commuting weeks per date range for the calculation. And this is an example calculation showing you how that commuting weeks per date range is entered. And so SIMAP just calculates through, multiplies through all of those different entry points, number of commuters, one-way trip per commuter per week, commuting weeks per date range, percent by automobile, so your different mode calculations here. So if you are going to enter multiple entries for a year to cover different time periods, it's important to make sure that number of weeks is accurate. We've also removed a couple of restrictions on commuting data entry that had been intended for quality control, but we think made it difficult to enter unique commuting data sets. So the first one that we removed is we now made it possible to enter multiple data entries by commuting type by date range. So for example, you could have 2 entries for student commuters over a given time period. Maybe you want to track undergrad student commuters differently from grad student commuters, for example. We also changed the modal entry so that it no longer needs to total 100%. So this particular example does not total 100%. Previously, you would have gotten an error from SIMAP because of that, and you wouldn't have been able to enter it. Now you can enter modes at less than 100%. And you might want to do this if for example, you have telecommuters tracked, you don't want to scale up to 100% because we don't have telecommuters in here right now. You now don't need to scale to 100%. Just a couple of general notes for commuting. Want to remind everyone to avoid double counting for scope 1 fleet vehicles, such as buses. So many campuses have their bus fleet in scope 1. They also have commuters that use the buses. So make sure if those buses are scope 1 that you're not also entering them in commuting. Also encourage you to check out the commuting report on the reports tab. This puts all of your commuting data in one place. So all of your commuting numbers, your mode entry, and then also has your results. So this is just a partial screenshot here because it's a long table. It can be exported as well. So you can use it to analyze and track your changes in commuting patterns over time. We've been getting questions about telecommuting because many campuses have a lot more telecommuters right now, and we're not adding this as a commuting mode right now, but it is something we're working on adding in the future. We've been working on this with the commuting working group and also working on some broader updates to standardize commuting data entry. And so telecommuting will be part of that broader update. But we did want to mention that telecommuting, a common misconception is that telecommuting doesn't have a footprint, but it actually does. There are emissions associated with telecommuting. And there's a lot of different ways that telecommuting can cause emissions. There are primary effects like the added at-home electricity use and heating that occurs when somebody's working from home, electricity that wouldn't be used if they were at the office or on campus. And there's also added server space and IT support to support telecommuters. There are also many secondary effects that get into aspects that are further removed, but still can be related and cause additional emissions. So for example, if someone telecommutes full time, they might live further away from the office and so have a longer commute when they do go in. They may have a larger house and have higher electricity and heating needs if they live further away. And so there are lots of different secondary effects that could be considered here. Our discussions right now with the commuting working group, and we also welcome feedback from all of you, is that we really want to focus on these primary effects and maybe even more specifically just on the added electricity required from at-home workstations. So here we have an example calculation just from a computer station, just the added electricity use from powering your monitor, your computer during work days. It's about 1 kilowatt hour per work day. And so that would be 4 weeks, 5 days per week, 20 kilowatt hours per month per person. If you multiply that out by 12 months and a US average CO2 emissions factor, it'd be just over 100 kilograms of CO2 per telecommuter per year. So that is smaller than commuting by a single occupancy vehicle on average, but it's obviously still pretty significant, especially if you have a large population telecommuting and if you also start to include some of these other effects like heating, added server space, and IT support. So we're continuing to research this. We've got some preliminary factors that we'd be happy to share if you're interested, and more will be coming on this soon. So how can SIMAP help? We have a lot of resources and services that we provide to help with your inventory. We wanted to point out first a few resources on the resources tab. There's a number of different links on the left panel here. The first one is tools. And this is where you can download the campus data collection template that you can import to your account. It's also where you can download the food data collection template, and there's some other links here as well. The user's guide is a detailed overview of background information and data entry in SIMAP, and there's also some basic account setup information on this page. And the training page is where we post all of our previous webinars and other training slide sets. So recently our team did a few short training videos, such as on data reviews and the UNH footprint. So those all get posted here. This is also where we will post our this webinar as well, the slides and the recording. The FAQ page has a lot of frequent questions that we get, so this can be a good place to go for general questions about account management, using SIMAP, and methods. And we wanted to focus in on data reviews here, and Cassidy Yates, who leads the data reviews, is going to tell us more about them. So,
thanks, Allie. So yeah, data reviews are an add-on service that we have to go over the data that you have in SIMAP, your results, and any imported files like the templates that you might have used. And with this data review, we help to identify outliers, gaps, inconsistencies, and errors in your data and maybe in how you're using SIMAP. We include a 1-hour video call to discuss the inventory and our findings after our review. And with these reviews, you can also earn ASHI Stars points. There's a few steps to do a data review. We first ask that you purchase the data review. It's now an add-on service for accounts that were upgraded after July 1st, 2020. And then you can fill out the Excel-based data review template. This is where we go in and add our comments, and we ask that you do a quick check of your data as well. Then you can email that file to us and fill out the request form on the data review page. And then after we complete our review, we go ahead and schedule that call with you to provide our recommendations. And just a quick look, this is the data review template. So anything in blue is where you would go in and check off and just do a quick scan of your data. And then we'll come and leave our comments in green. And then yellow is where we leave any comments from our data review call. So we look forward to working with you if you happen to request a data review. Thank you.
Great, thanks so much, Cassidy. So just a few other brief SIMAP updates here before we get to the Q&A session in just a minute or two here. We have 3 ongoing working groups. So we mentioned the Commuting Working Group, which we've been working on and some updated commuting guidance, and also been working on with the telecommuting calculations. The Bioenergy Working Group has been continuing to consider questions about biogenic emissions and campus land management, and provided feedback on the biogenic report that we shared today. And the Nitrogen Working Group was just launched earlier this week, actually. Or last week, very recently. And so it's co-facilitated with the University of Virginia. And if you are interested in participating in any of these working groups, please reach out to us. So to summarize, we've released some new functionality that we went over during this call. Biogenic emission factors have been separated out, and there's a biogenic report to view those results. Ben explained to us the 2020 version of emission factors, the 20-year global warming potentials, and some new air travel methods. We've also tried to highlight the recommended methods and added a number of content pages to provide more background on all of these topics. And there's a lot of resources on SIMAP that provide more background information that we encourage you to check out as you're working on your inventory. Cassidy explained the data review process, and we encourage you to request a data review and be happy to take a look at your data. And we have ongoing working groups that are discussing these new and cutting edge topics in carbon and nitrogen footprinting. And as always, please reach out to us with any questions that you've got at simap@unh.edu. So with that, we're ready now to take your questions. So I'll turn it over to Jen, who's going to be walking us through the questions that have come through.
Thanks, Allie. And thank you all for some great questions already, and obviously keep adding them if and as they occur to you. So we had a question early on about the ability to add historic data into SIMAP. And I think partly that's because some of the results views, the reports views we were showing, the reports are generally 1 year of data, but you definitely can enter historic data. You can enter data for any number of years in SIMAP, and you can do that either by entering individual data points for individual years, but we also have the capability, some templates to upload historic data. On the resources tab, there's an upload template. So if you have historic data that you want to kind of bulk enter into SIMAP, you can do that. Allie, anything else we should say about that question?
No, that's great. Thank you.
So then we'll kind of work our way backward here. So telecommuting, there was some interest in some of those telecommuting statistics and questions. So for example, would telecommuting be added to scope 3 emissions in a future version? Yes, that is what we are working on doing. And as Allie said, kind of trying to figure out what is the best way to do that in terms of bounding emissions factors. And the statistic that you shared, Benjamin, around turning on your camera during meetings increases energy use up to 90%. I've never heard that, so that's astounding and helpful. Allie, do you want to say anything about kind of the process, any more about the process by which we intend to kind of move toward including telecommuting in scope 3?
Sure. Yeah, thanks, Jen. So what we're working on right now is setting those system bounds to determine which of those different aspects of potential emissions from telecommuting should be included in the emissions factor. This is a pretty new area of research, and there have been a number of studies on the added emissions from telecommuting, but as you can imagine, it can vary substantially. And the scoping question, so first getting an average for a particular category is what we're working on, a representative average, and then also figuring out the system bounds for it. So if we include just those very direct added electricity emissions from your home workstation, or should we also be including added electricity from just being at home, added heat from being at home? I think we've ruled out incorporating any of those secondary effects, such as folks that might live further from home, have different travel patterns as a result of telecommuting. And I think we've decided to focus in on those primary effects, but there's a few different levels at which we could set it. So any feedback that you all have, any studies you come across, we've been compiling those. We would love to hear from you about that. But basically the way the calculation will work is it'll be an additional mode that you can enter in commuting entry. So you can say what % of your commuters are telecommuters. And then we'll be using the location-based eGrid emissions factors based on the added electricity use. And if we have added heating use, we'll be using the average heating emissions factors for your natural gas and other at-home heating sources. So that's how the calculation will work. You'd be able to view your telecommuting emissions on the commuting report and also as a commuting mode in the categories view as well.
And I suppose we could think about too how to make those customizable. I'll just add that, so we have this telecommuting working group that Ali referenced, who meets generally once a month, first week of the month. Always welcome new members. If you guys are interested in helping work through how we should look at that, please let one of us know that you may be interested in joining that working group, because we'd love to have you. I want to touch on this airline travel emissions calculations question, and then we'll get to the questions about the new reports around land use and carbon neutrality. But Ben, maybe you can speak. So we have a question around just speaking to how the airline travel emissions calculations via dollars are statistically verified. So maybe you can speak a little bit more to that data source.
Sure.
And then Amy, if we're not answering the question and you want to follow up, if you want to unmute yourself to ask directly, you could. That would be fine.
Yeah, thanks, Jen. So I touched on this a little bit before, but our new data source for these conversion factors is the Bureau of Transportation Statistics Airline Origin and Destination Survey, which has the initials DB1B, and you can find this on the Bureau of Transportation Statistics website, or they call it TransStats, Transportation Statistics. What it actually is a survey of 10% of all of the airline tickets issued by airlines in the United States. And so they use this data and provide these statistics for a variety of reasons, including things like airline market share, things like this. But we take the data that specifically is about fare and miles flown, and they actually do that calculation on their own to provide a fare per miles flown. And then we download that data and into R, and then using R, we just remove some of the largest outliers. We're not very selective there. We're kind of trusting that the Bureau of Transportation Statistics is providing us with pretty accurate data. And then we just take the median values for each year. And that's what we use to come across our factors.
Amy,
just one thing to add to that is Ben did a lot of statistical analysis on that data set, because as he mentioned, it had millions of data points. And so we looked at different calculations like the average and the median. We thought the median was best because there were some high values. And as Ben mentioned, we also removed outliers and found that the median was not very sensitive at all to us removing those outliers, but we still removed some, like values of 0, for example. So if anyone has any questions about the specific steps we took, we'd be happy to share the details of the steps that Ben took for calculating those factors.
Okay, thanks you guys. So I think the last kind of round of questions is really curiosity and interest in the coming soon reports that you mentioned, Ali. The land use report and the carbon neutrality report. So I'll maybe start this off, and then Ali and Ben and Cassidy, if you have anything to add, please do. The Biogenic working group started last, I think it was last year, was formed to tackle kind of a couple of obviously very related questions. One around that all kind of center around what is the carbon impact of land use and of the use of biomass and other biogenic sources. And so one piece of that is, what are the emissions that result when you burn them? But another piece is, what is the potential for carbon sequestration? So we have members of that working group that are interested in being able to understand the impact from an emissions perspective of what they're burning. But we also have many members who are interested in better understanding and better incorporating into their inventories the impact of their land use decisions, the land that they're conserving, what would happen if they didn't, what would happen if they built new buildings. And so kind of capturing the avoided emissions from, not developing or from keeping conservation land conserved. And then also interest in the ability to calculate changes in land use management or enhanced practices for enhanced carbon sequestration, whether from forests or soils or both. So we've begun those conversations, and there's some great, you all may be more familiar than I, and I know we have a couple members of that working group on this call. There's a lot of great science out there. There's increasingly a number of great tools out there to kind of apply that science to do these calculations. And so what we're working on right now is to just try to understand what those existing tools, methods, the available data are, and then to work through a conversation with that working group about how best to incorporate that science into SIMAP to give users the ability to have a number associated with their land use, both active annual sequestration and potentially also avoided emissions from not doing something different. So we haven't gotten, I guess we're still relatively early in the process, so we can't, for example, preview what that report might look like. Mostly this is an invitation to, again, anybody who's interested who isn't already in the Biogenic working group to consider taking part. And for those that are, thank you again for being part of those conversations. And clearly there's a lot of interest in it. So kind of similar to the telecommuting piece, if people have studies or tools or other things that they would like us to be aware of, so we can think about how we could reflect those resources and SIMAP and the science behind them, would love to hear about those. We will, of course, if and as we have ideas about how to incorporate, be coming back out to our user community, you all, to say, what do you think about this? What do you think about that? So I would expect to hear, watch the newsletter, watch announcements for webinars, because we're definitely not going to include or add anything without getting some more feedback from the community. We're definitely not there yet. And then the carbon neutrality report, the idea is that everybody needs some additional tools for figuring out how to put these pieces together, the existing kind of inventory emissions, the biogenic emissions, and the sequestration potentially from land use, to be able to understand how they fit together and do or do not add up to carbon neutrality, depending on how you define carbon neutrality or bound it differently. There's lots of approaches to that. So that is even, I think, maybe step 3, a little further down the road, but it's something we're planning for. So I think the same invitation goes. If you have ideas about that, let us know. If you want to be part of the working group, let us know. And if and as we make incremental progress, we will be sure to share it with you all and ask for your feedback. So mostly that's a more soon, and please be in touch. Allie, Ben, anything you want to add on that front?
I think just that we're also considering other reports to add in the future, and we welcome suggestions for topics that you think more information would be helpful. One that we've been hearing from you all is having more on scope 2 in a report, so more on renewable energy purchases and how the net scope 2 electricity is calculated. So it's another topic we're considering for report, and we welcome other suggestions that you all have for topics that you think more information and a deeper dive would be helpful.
Wonderful. I see we are at about time. Allie, Ben, Cassidy, anything to add by way of wrap up before we let everybody go?
I don't think so. Just thanks everyone so much for joining us today. If any other questions occur to you, please reach out to us by email, through the Google form, leaving a voicemail for us, and encourage you all to request data reviews. We've enjoyed working with many of you on the data reviews already, learning more about your campuses and your inventories and getting to know all of you better. So we look forward to continuing to work with you on your inventories.
All right. Well, thank you all again. Have a great afternoon.